Okay, on number 9, we just need to analyze the problem to see if there's an error. I'm going to start by reminding you that when you have f of g of x, that means the g function gets plugged into the f function. So I'm just going to show that this is going to get plugged into all of the x locations of the f function. So if we rewrite that, we would end up with 5 main fraction bar over -3 over x. Okay, so that looks really exactly like that one. We can check to see if there's a mistake in this simplification. One thing that you need to remember, though, is the domain of the first function. So the domain of the input function, we need to check into that, because notice that here we have x in the denominator. That means that the domain for g of x cannot equal 0. So x cannot equal 0. All right? So that means that we're automatically restricted with the domain of the composite function. If the domain of the g function can't be 0, then certainly the domain of this function cannot be 0. So we're just going to say the domain of f of g of x is not equal to 0. All right, so we've established that. All we have to do now is just check to see if this is all okay. So we're going to say 5 over 1 divided by -3 over x, which means 5 over 1 times x over -3. That gives us 5x over -3, which is essentially the same thing that we've got here. Okay? So, yes, the student is correct, with the exception of not having mentioned that the domain cannot include 0 on the composite function.